Dear students, today we will discuss about the binary subtraction. The binary subtraction is similar to the decimal arithmetic, and it is column wise, that is bit wise operation are performed. There are two parts. First is the minuend and the subtrahend. These two are the assigned to you, and you have to find the difference. And to perform this difference, the borrow may be generated or required or may not be required. Since we are operating on binary number, the result either 0 or 1. So 0 minus 0. 0 minus 0, the result is 0 without any borrow, because both are the same digit. So when the minuend is 1 and the subtrahend is 1, then the result is 0 with borrow 0. And 1 minus 0, the borrow is 0, means without any due we can subtract 1 minus 0, so the difference is 1 and the borrow is 0. So these three cases, borrow not generate. The 0, minuend is 0 and subtrahend is 1. So the difference is 1. Look at 0 minus 1. So the difference is 1. But since 0 is less than 1, so that's why we require a borrow. Our previous discussion in form of truth table, that 0 minus 0, the borrow is 0 and the difference is 0 minus 0 is 0. 0 minus 1, so the borrow will generate because m is less than s, so borrow out is 1 and the difference obviously 0 and 1, the difference between these two is 1. In the third case, 1 minus 0, so we can easily subtract 1 minus 0, that borrow out is 0 and the difference between m and s is 1. And the case of 1 1, the borrow out is 0 and the difference between these two number is 0. So this is the truth table. So look at this truth table can be implemented as b out equals to m bar s, that only this case where m bar equals to 0 and s equals to 1. So b out equals to m bar s, and the difference is nothing but the XOR gate. So 0 0 0 1 1 0 1 1, forget about this line. So 0 0 0 0 1 1 1 0 1 and 1 1. This is the similar output of XOR gate. So the difference is expressed as m bar s plus m s bar. So it is the a XOR gate. So this is the XOR gate. We require m bar, so that's why the NOT gate is required, and AND gate is required to perform m bar s. So suppose SM is the 2 input, so we have to connect the XOR in this fashion, and m bar, this is m bar, it is connected with the AND gate, and other terminal of AND gate, input terminal of AND gate is connected with S. So the output is B out. So the B out is M bar S. So this is called the half subtractor because the previous borrow is not considered. Now look at, these are the previous borrow input. So this borrow out is the input of this block. This block is generate also a borrow out, and this borrow out is work B in, and this borrow out is work B in for this device. To operate this device, we require a synchronized clock pulse. That clock pulse is synchronized, means that it control that when this block will on or off. Let's assume, so these are the initial borrow B0, M, S, and the output is D0 with borrow B0. If the borrow is generated, then it will be placed for this. If the borrow is generated in this operation, it will propagate to its higher significant bit. So this is B0, that initial borrow input, M0 and S0, because it operates bitwise, so we have to write in this way. Now this is for bit 1, this is for bit 2, and this is for bit 3. So it is a 4-bit subtractor. So how it operates? MS minus borrow in. MS minus borrow in. Suppose the value of M is 0, S is 0, and the input borrow is 0. So 0 minus 0, first we have to calculate the difference between M and S, and that difference again compare with B in, and we have to find that difference. And if in any intermediate operation borrow generated, we have to consider that borrow and it will propagate to its next higher bit. So M minus S minus borrow in equals to the difference D along with the borrow out. So M minus S, we have to perform it first. So obviously it will generate the difference intermediate and the intermediate borrow 1. In the second step, this difference intermediate minus borrow in give you the intermediate borrow 2 and the difference. So the borrow intermediate borrow 1 or intermediate borrow 2, if anywhere the borrow is generated, it will be the final result. So the final result can be expressed as D, which is nothing but the difference intermediate minus borrow in, and the output borrow is the OR between the intermediate borrow 1 or 2. So look at M minus S minus B in equals to B and D. We have to perform M minus S, that is BS1 ds1, that is step 1, the borrow of step 1 and the difference of step 1. b s1 is expressed as m bar s. We already performed this operation at the starting, and ds1 is nothing but the XOR gate. So this is the half subtractor which we have already performed. Go through this half subtractor. Now this half subtractor is used also here. Why? Because ds1 minus b in, that is ds1 minus b in, it's give you the difference, and this is the borrow in. So ds1 b in is the borrow out, and m XOR s XOR b in. Look at this, the difference, and this difference is entered into here. So obviously we can express this d as m XOR s XOR b in, and the b is the intermediate borrow output or this step borrow output. So this will be in OR gate. So using two half subtractor, we may realize a binary full subtractor. In case of half subtractor, the previous borrow, that is the borrow in, is not considered. Means we just subtract between these two numbers, a and b. Obviously a is minuend because we use here at the NOT gate, okay, and the output of this XOR gate is fed to the half subtractor of its cascade connection. So these are the logic gate. This is the realization of full subtractor using two half subtractor. So let's follow this rule. We have minuend, subtrahend, difference, borrow out and borrow in. Okay. So this is the formula. We already gone through it. So 0 minus 0, look at the rules. 0 minus 0 is difference is 0 with borrow out 0. This borrow out is propagate into the next. So this borrow may be 0 or 1. Let's consider the borrow in is 0. So 0 minus 0 minus 0 is 0, and the borrow out is 0. Now if the borrow in equals to 1, so this one obviously 0 minus 0 is 0, and 0 minus 1, 0 minus 0 is 0, and that 0 minus 1, so it is not possible to subtract without considering the borrow. So we have to consider the borrow out, and the difference is 1. So we tabulate this thing. Now the another case, because 3 input, so the possible combination is 8. So we already performed 2 case. Now what about the other 2 case? So look at 1. Previously the minority was 0, now it is 1. So 1 0. So 1 0, obviously 1 minus 0, the difference is 1 without any borrow. Now if the previous borrow in equals to 0, so 0 minus 1, 0, 1 minus 0 is 1, with minus 0, obviously the difference is 1 and the borrow out is 0. So we express it with addition of another table, that 1 0 1 0. Minuend is 1 and subtrahend also 1. So 1 minus 1, the difference will be 0 and the borrow out is 0. So if the borrow in is 0, so it not affect this result. So 1 minus 1 is 0, difference is 0, and the borrow out also 0, and the 0 minus 0 is 0 and the borrow out is 0. Now for the next case, 1 1. Now for the next case, that both are 1, meaning a subtrahend 1, and the borrow is also 1. So 1 minus 1 is 0. So 0 minus 1. So 0 minus 1 is 1 with borrow 1. So it will be represent as 1 0 with borrow 1 is difference is 0, borrow out is 0, and the 1 0 with borrow 0. So this is the case 1 1 0 0 1 1 1 1 1. So minuend is 1, subtrahend is 1, borrow is 1, and the difference also 1. Now for this case, in this case absolutely it is fine. 0 0 minus 1 is minus 1, minus 1 0 minus 1, the difference is 1 with borrow 1. This is not a big issue. Now for this case, where the borrowing equals to 1, so 0 minus 1, the result is minus 1, and there is minus 1 and 1. So we have to difference in this way. 0 minus 1, the intermediate difference is 1 with borrow 1, and 1 minus 1. So the difference is 0. So in this case, the minuend is 0, subtrahend is 1, borrow in is 1, and the difference is 0. How? Look at the step once again. 0, 1. So 0 minus 1 minus 1. So first we have to calculate 0 minus 1. Here the difference is 1 with borrow out 1. So if the borrow is generated, we have to write the borrow out. Now the difference is 1. First step. So 1 minus 1. So 1, 1, the difference is 0. So we have to write here 0. This operation, look at the position of point. Here the point is before 2 digit. Here the bit after this point is 2, and here the number of bits is 4. So we have to write the point in a particular position. So 1, 1 in the same position, 1011.1011, and for this point 0, 1 and 1, 1, 0, 0, 0, 0, 1. So we have to pad 0. This is called the 0 padding. Look at the result of these subtractions. The point should be the similar place. So for first, here the borrow in is 0. We have set as 0. So 0 minus 1. So the difference is 1 with borrow 1, 0 minus 1 with borrow 1, and this one, for this case 0 minus 1, the difference, intermediate difference is 1. So 1 minus 1, the difference is 0 along with the borrow 1. 1 minus 0 is 1, 1, and the 1 minus 1 is 0 with borrow 0. 0 minus 1, obviously 1 with borrow 1. Now 1, 1 minus 1, 0, 0 minus 1 is 1 along with the borrow 1, 1. Again it is 0, 1, 1, 0, 0 minus 1, the difference is 1 with borrow 1. This is 0 minus 1, so the difference is 1 with borrow 1. 0 minus 1, 0 minus 1, the difference is 1 with borrow 1, and this difference minus borrow, it will be 0 with borrow 1. 1, 0, 0 is 0, so 0 minus 1 with difference 1 with borrow 1. 0, 0, the result is 0, 0 minus 1 is 1 with borrow 1, and 1 minus 0 is 1 without any borrow. So 1 minus 0 is 1, borrow is 0, and 1 minus 1 equals to 0. So this is the answer. So this is the answer. Hope the problem of binary subtraction is over. In the next video, we will learn the binary subtraction using the addition method.